In this lesson, I will explain to you the concept of depth first search in artificial intelligence. So here I have written some information and then I will give you example as well. So DFS is an algorithm for traversing or searching tree or graph data structure. The algorithm starts at the root node and explores as far as possible along each branch before backtracking. So, see, this is the important line. What is the meaning of it? I will explain to you. And here it will use the LIFO method, means last in, first out, which is known by stack. In BFS, it uses FIFO or Q, and here it is using stack or LIFO, right? Before going to start, one more thing I want to explain here, that DFS also comes under the category of uninformed search, which is also known by brute force technique or blind search. What is the meaning of blind search? That we only know from where to start. See, here we can start from A, then we have two routes B and C, but from B and C we are not sure. We do not have information how to reach to our destination or our goal state. Suppose our goal state is D or E or H, whatever. We do not have any idea if we are using DFS, and DFS belongs to uninformed search where we do not have domain knowledge, right? Okay, so I will write down step by step what are the important points here, because these points can come in your MCQs as well. It follows stack. Stack means LIFO. LIFO is last in, first out, right? And then is the deepest node. What is the meaning of deepest node? And then is incomplete. Okay, I will explain all these terms. First of all, you have to keep in mind it uses LIFO and it is known by stack method. Deepest node, suppose if it will start from A, we know this is the starting point. Then it will go to C. From C, suppose it will go to F. If we have further nodes here, it will go step by step. So it is called the deepest node. Right now, how it works, I will explain you. This is my example. I only know that it starts from A. This is my starting point, and suppose we can say this is our goal state H. We have to reach here. We do not have any information, right? So we will start from A because only we know this thing. A is our starting point, and then you know that there are two routes, right? A can go to B and A is also going to C. So here I will write down, this is the stack, right? Stack B, and on the top this is stack C. But again, this is the not rule. You can write down C first and B then, right? So but I am going alphabetically A, B, C. That is why I have written B and C. So this is my first stack. So see what I have written in the last, C. And it is LIFO, last in, first out. So I will cross this. It means I will go, my path is A to C. And then you have to see, is there any branches from C, or this is the parent? Is there any children from the C? Yes, we have three children, D, E and F. So see here, I will make a separate stack here. B we already have, so we will write down B, then we have D, then we have E, then we have F, because these are the children of C. So what I have written at the last, LIFO, according to LIFO F. So I will cancel this out. It means my next step will be F. I will go from A to C, then C to F. Right? And from here, F, I will see first whether this is my destination, my goal state, or no. No, this is not my goal state. If we have further nodes, then we have to move here, here, here in the same way. But as you know, we do not have any further extension from this F. Now it will go backward or backtracking. So it will again move to C, and C is the parent of this F. C we already have used here. Now it will move to E because we have E here, right? I will cross this E according to LIFO and I will write down E here. Then my fourth move will be to E. Here I have to check whether I have further extension, further kids. No, I do not have. So what I will do, I will go back to my parent C, and from C, as we have already used here, so then I will move. If we already use, we will not write down again. So here from D, right, my next move is D, and I will remove this D. Is there any further branch from D? No, we do not have. So what it will do, it will go backward to C, to this parent. C is the parent of D and A is the parent of C. It will go back here. Then it will come to the B. This is B and we have B here. So we will cross this B and then we will see whether we have branches. Yes, we have G and H. So I will write down H. You can write down in any order, right? G. So G is here, right? This is according to LIFO. I have to cross this out, means last in, first out. I have to take it out and then I will see. We have further, I will write down G here. We have further branches? No, it means it will go backward. B. B is the parent of G. We have already used B. That is why we will not write down again. It will come to the H. And here is H. When I will remove this H. So see here, in order to reach our goal state, according to DFS, our route is A to C, C to F, then E, D, B, G, H. First, depth wise, it will go depth wise. If we have further extension, it will come here, it will move here, it will move here, right? So this is the deepest node. That is why it is called the deepest node. And sometimes we have too many kids here. It is impossible for us to find the optimal solution. That is why it is said it sometimes it is incomplete or no optimal solution. In BFS, we move like this, right? First, we have to cover this level wise, these nodes, and then these nodes and this nodes. But here in DFS, we have to follow a pattern depth wise. If we could not find out our destination, then we will backward tracking. We will do backward tracking, right? So sometimes in loop we stuck. So that is why we say this process is incomplete or we cannot have optimal solution. Now about what is the time complexity is. Time complexity is order of B raised to power D. B means branch factor, how many branches we have. D means depth, right? Depth. So suppose here this is our goal state. Suppose, right? D is our goal state. So we will see if from each node we have two kids. This is the case I am telling. This is our goal state and from each node we have two. So B branching means 2 and then this is our depth 0. This is 2. This is, sorry, this is 1. This is 2. Raised to power 2, it means 4. It will take maximum 4 moves to reach here. When if we have two kids from each branch. If we have three kids from each branch, so branch is 3, right? Then we have to see in which depth we have that our destination. Our destination is here. So 3 times 9, it does not mean 3 2 times 6. 3 times 9 up to 9 attempts, right? Maybe less than, but not more than 9. We can find out our destination. When if we have 3 kids from each node or each parent, right? And here I have written some difference between BFS and DFS. BFS follow the Q, which is called FIFO, and we had discussed FIFO in our last lesson, so you can please watch there. DFS is using a stack or LIFO, last in, first out. It is level or shallowest node, means each and every node. Suppose if we have 2 or 3, it will go like this. But this DFS depth wise, right? If it will not find out the destination, then it will come back and then follow the another path. Here we will get optimal solution or complete. Here may or may not be. Why? Because sometimes the nodes are, there are too many nodes, right? And we stuck in the loop, so that is why sometimes may or may not be. So I hope the concept between BFS and DFS is clear. Both comes under the category of uninformed search. So please practice it, subscribe to my channel, and thanks for watching.